Welcome to the session on theory of equations, multiple roots and relation between roots. An expression of the form f of x is equal to a naught x raised to n plus a1 into x raised to n minus 1 plus etc. plus a n minus 1 plus a n, where a naught, a1, etc. a n are constants and n is a positive integer, is called a polynomial in x of degree n, provided a naught not equal to 0. The equation f of x is equal to 0, that is a naught x raised to n plus a1 x raised to n minus 1 plus etc. plus a n minus 1 plus a n is equal to 0 is called a polynomial equation or an algebraic equation of nth degree, provided the coefficient a naught not equal to 0. Alpha is said to be a root of the equation f of x is equal to 0 if f of alpha is equal to 0. If alpha is a root of the equation f of x equal to 0, then we can say that x minus alpha is a factor of f of x, which is known as the factor theorem. If alpha is a multiple root of the equation f of x is equal to 0, that is if alpha is a repeated root of multiplicity of order r for the equation f of x equal to 0, then alpha is a multiple root of multiplicity r minus 1 for the equation f dash of x equal to 0. We have to prove this theorem. Let the degree of f of x is equal to 0 be n. Consider an equation f of x equal to 0 whose degree is n. Then, since alpha is a multiple root of multiplicity r, we can write f of x as f of x is equal to x minus alpha whole raised to r into phi of x, where phi of alpha not equal to 0. Therefore, on differentiation we can write f dash of x is equal to, here x minus alpha raised to r into phi of x, this is a product of two functions. We can apply the product rule for differentiation. The derivative is f dash of x is equal to x minus alpha raised to r into derivative of phi of x is phi dash of x plus derivative of x minus alpha raised to r is r into x minus alpha raised to r minus 1 into phi of x, that is equal to x minus alpha raised to r minus 1, x minus alpha raised to r minus 1 into r into phi of x plus x minus alpha into phi dash of x. This is equal to x minus alpha raised to r minus 1 into some psi of x, where psi of x is this function r into phi of x plus x minus alpha into phi dash of x. Clearly, from this phi of x, we can say that psi of x, we can say that psi of alpha is equal to 0, because for x is equal to alpha, this term will become 0. Psi of alpha not equal to 0, because psi of alpha is equal to r into some phi of alpha. This is not equal to 0, because phi of alpha is not equal to 0, which is our condition. Therefore, the function at alpha, that is psi of alpha, is not equal to 0. Therefore, we can say that this function f dash x has a root of has a root alpha of multiplicity r minus 1, because we can write f dash x as x minus alpha raised to r minus 1 into some function of x, where psi of alpha is not equal to 0. Therefore, we can say that f dash of x equal to 0 has a root alpha of multiplicity r minus 1. Here the multiplicity is r minus 1. This is the proof. Now, consider the equation x cube minus 4x square plus 5x minus 2 is equal to 0. Given that this equation has a double root, this is the given equation which has a double root, then solve this equation. We take f of x as the left hand side function x cube minus 4x square plus 5x minus 2. Here, assume that f of x equal to 0, that is x cube minus 4x square plus 5x minus 2 is equal to 0, has a double root alpha. Then, from the above theorem, we can say that f dash of x equal to 0 has a root alpha. That is, here f dash of x is 3x square minus 8x plus 5. Differentiating this function with respect to x, we will get 3x square minus 8x plus 5, and f dash of x equal to 0 implies 3x square minus 8x plus 5 is equal to 0, has a root alpha. Now, consider this left hand side 3x square minus 8x plus 5. We can factorize this as x minus 1 into 3x minus 5. This equal to 0 implies, this implies x minus 1 is equal to 0 or 3x minus 5 is equal to 0. That is, x minus 1 equal to 0 implies x is equal to 1, or from this 3x minus 5 is equal to 0 gives x is equal to 5 by 3. Now, we take x is equal to 1 and substituting this function, we will get f of 1 is equal to 1 cube, that is 1 minus 4 into 1 square plus 5 into 1 minus 2. This equal to 1 minus 4 plus 5 minus 2, that is minus 3 plus 5 minus 2, that is 2 minus 2, which is equal to 0. Therefore, x is equal to 1 is a double root. And we can write f of x as f of x is equal to x minus 1 the whole square into x minus 2. Therefore, the roots of the given equation are 1, 1 and 2. The given equation is a third degree equation. Therefore, there exist 3 roots for this third degree equation. Now, we shall discuss relations between the root and the coefficients of an algebraic equation. Let alpha 1, alpha 2, etc., alpha n be the n roots of the nth degree equation f of x is equal to a naught x raised to n plus a 1 x raised to n minus 1 plus etc. plus a n is equal to 0. Then we can write x minus then we can say that x minus alpha 1, x minus alpha 2, etc., x minus alpha n are the factors of f of x. Therefore, a naught x raised to n plus a 1 x raised to n minus 1 plus etc. plus a n can be written as a naught into x minus alpha 1 into x minus alpha 2 into etc. into x minus alpha n. This is equal to a naught into on multiplication we will get x into etc. into x, that is n times x multiplied, that is x raised to n, minus we can write summation alpha 1 into x raised to n minus 1 plus next is summation alpha 1 into alpha 2 into x raised to n minus 2 next is negative sign etc. plus minus 1 raised to n into alpha 1 alpha 2 into etc. alpha n. Where we denote SR by summation alpha 1 into alpha 2 into etc. into alpha r, that is this is the sum of the products of the roots alpha 1, alpha 2, etc., alpha r taken r at a time. This is the product of the roots alpha 1, alpha 2, etc., taken r at a time. Now, equating coefficients of like powers on both sides, we get minus s 1 into a naught is equal to a 1. That is a 1 is a 1 into x raised to n minus 1 is in the left hand side. In the right hand side, the term having x raised to n minus 1 is a naught into negative of summation alpha 1 into x raised to n minus 1. On equating, we can write this minus, this is our S1. Therefore, minus S1 a naught is equal to A1. S2 into a naught is equal to A2. That is the next term is in this side, the next term is A2 into x raised to n minus 2. In the right hand side, the term having x raised to n minus 2 is a naught into summation alpha 1 into alpha 2. By this notation, this is our S2. Therefore, a naught into S2 is equal to A2, that is the coefficient of x raised to n minus 2. Similarly, minus S3 a naught is equal to A3, etc. Minus 1 raised to n into Sn a naught is equal to the coefficient an. From this we can write S1 as S1 is equal to minus A1 divided by A naught. That is, S1 means summation alpha 1, which is equal to minus A1 divided by A naught. From this expression, we can write S2. S2 equal to summation alpha 1 into alpha 2, which is equal to A2 divided by A naught. From this, we can write S3 is equal to summation, S3 means summation alpha 1 into alpha 2 into alpha 3, that is the sum of the products taken 3 at a time, which is equal to minus A3 divided by A naught, etc. From this, we can write Sn as Sn is equal to, Sn means sum of the products of n roots, that means alpha 1 into alpha 2 into etc. alpha n, which is equal to minus 1 raised to n into a n divided by a naught. These are the relations connecting the roots and the coefficients. These relations are not sufficient to find the values of the roots alpha 1, alpha 2, etc. alpha n. If an additional condition satisfied by the roots is also given, we can find the values of the roots alpha 1, alpha 2, etc. alpha n. Now, consider the example. Solve the equation x raised to 4 minus 6 x cube plus 13 x square minus 12 x plus 4 is equal to 0. Given that this equation has two pairs of equal roots. The given equation has two pairs of equal roots. We want to find all the roots. That is, the given equation is a 4th degree equation. Therefore, this has 4 roots. The given condition is that the two pairs are equal roots. Assume alpha and beta be the double roots. We assume alpha and beta are the double roots of the equation f of x equal to x raised to 4 minus 6x cube plus 13x square minus 12x plus 4 is equal to 0. Let it be f of x. Since alpha and beta are the double roots, we can say that for the given equation, the roots are alpha, alpha, beta and beta. These are the 4 roots of the equation x raised to 4 minus 6x cube plus 13x square minus 12x plus 4 is equal to 0. Now, from these relations, we can write S1. Here, this is alpha 1, second one is alpha 2, this is alpha 3 and alpha 4. 4 roots are there. Now, S1 means summation alpha 1, that is alpha 1 plus alpha 2 plus alpha 3 plus alpha 4, which is equal to, in this case, alpha plus beta plus beta, that is 2 alpha plus 2 beta, which is equal to 2 times alpha plus beta. But from this relation, S1 is minus A1 divided by A0. Here A0 is 1, coefficient of x raised to 4 is A0, A1 is minus 6, A2 is 13 and A3 is minus 12 and A4 is 4. Therefore, we can write S1 is equal to minus A1 by A0, that is S1 equal to minus A1 is minus 6 divided by A0 is 1, that is 6. Therefore, we can write 2 times alpha plus beta is equal to 6, implies alpha plus beta is equal to 3. S3 equal to the sum of product of 3 taken at a time. From this we can write S3 as 2 times alpha square beta plus 2 times alpha beta square. That is from here we can write S3 equal to alpha 1, alpha 2, alpha 3 plus alpha 1, alpha 2, alpha 4 plus alpha 2, alpha 3, alpha 4 plus one is this alpha 2, alpha 3, alpha 4 and alpha 3, alpha 4, alpha 1. Alpha 3, alpha 4, alpha 1. Alpha 1, alpha 2, alpha 3 means alpha square beta. This is alpha 1, alpha 2, alpha 4 also alpha square beta. Alpha 2, alpha 3, alpha 4 means beta square alpha, that is alpha beta square plus this also alpha 3 into alpha 4 means beta square, alpha 1 is alpha, that is alpha beta square, that is 2 times alpha square beta plus 2 times alpha beta square, which is S3. From this relation, S3 equal to minus A3 divided by A0. In this case, we can write A3 is minus 12, S3 equal to minus of minus 12 divided by 1, that is 12. Therefore, we can write 2 alpha beta into alpha plus beta is equal to 12. Because alpha plus beta is equal to 3, from this expression we can write 2 alpha beta into 3 is equal to 12, that is 6 alpha beta equal to 12, which implies alpha beta is equal to 12 by 6 equal to 2. Solving, we have two relations, alpha plus beta equal to 3 and alpha beta is equal to 2. This is equation number 1 and this is equation number 2. On solving, we will get alpha is equal to 1 and beta is equal to 2 or alpha is equal to 2 and beta is equal to 1. Therefore, the required roots of the given equation are, the roots are x is equal to 1, 1, 2 and 2. With this example, let me conclude this session. In this session, we discussed on the multiple roots, and we discussed some relations connecting the roots and coefficients of the equation of the form f of x equal to 0. Hope that you have understood the session. Thank you for watching the class. Have a nice day.